Hello, we are covering, let's see, what are we covering today? 2.2, graphs of functions. So take notes. All right, so 2.2, we're going to do this also in two parts. So graphs of functions. Okay, so what we're going to be doing here is we're going to take a look at some parent functions, and we're going to take a look at how to graph them just by analyzing the function itself and checking to see how we shift the function, the parent function. Okay. All right, so we have some basic functions here. These are known as the parent functions. So we have the linear function. And that has this form, f of x equals mx plus b. Okay, and this here has the graph of a line. Maybe it goes up from left to right, or maybe it goes downward left to right. Okay, and then we have our power functions. So those are like f of x equals x squared, which we know is the parabola. F of x equals x cubed. That's this sort of snake. And f of x equals x to the fourth. You know what? Let me do this. I'll do it this way instead. Because what happens is x to the fourth, x to the sixth, they all pretty much have this form, except that right around 0, it's more flat, depending on the exponent, as the exponent gets higher. So whether you have x to the fourth or x to the sixth, x to the eighth, etc., you have it more flat, but it's not completely flat. Okay, so you think, and that's between -1 and 1. So try to imagine these fractions like 1/3, and you're raising it to the 6th power. So now that denominator gets bigger. So it's like 1 over a big number, which is close to 0. Okay, so that's why it gets more flat as the exponent increases. Okay, and then same thing here, whether you have x to the 5th or x to the 7th, etc. It'll have a similar graph to x cubed, but again, between -1 and 1, it'll be a little more flat. Okay, and even more flatter as the exponent increases. Okay, between -1 and 1. All right, and then we have our root functions. And we have f of x equals square root x, and that's like the top half of a sideways parabola. So imagine a parabola that's sideways, but then you only have half of it. So you only have like the top half. Okay, f of x equals the cube root of x. So that's kind of like your sideways x cubed. Okay. And then the same thing with f of x equals the 4th root, 6th root, and then here the odds. Okay. And this here, you can imagine when you take the 4th root of 4, you get 2, but when you take the 4th root of, when you take the square root of 4, you get 2, but when you take this 4th root, then you have a smaller number. Okay, so it's not as high as square root. And then same thing here. Okay. All right. So then we have our reciprocal functions. Reciprocal functions. So you have something like this: f of x equals 1 over x. So you have a function that looks like this. And then we'll take a look at 1 over x cubed. And then here we'll take a look at 1 over x squared. Even powers, odd powers, right? Okay, so 1 over x looks like this. The branches are opposite, like that. And over here, when you have 1 over x squared, then you have this. You have a branch here, and you have a branch there. And so then when you have, so these top ones here, this is for like the odds, x to the first, x cubed, x to the fifth, etc. And what happens here is your graph gets kind of closer in towards the origin. And then same thing here. Closer in towards the origin as that exponent increases. Okay. And then we also have the absolute value function. That is the one that looks like a V. F of x equals absolute value of x. And that is that V function. Okay. And then we have greatest integer function, but I will get into that in part 2 because we'll take a look at how to graph greatest integer. Okay, so let's take a look at graphing linears first. Okay, so let's take a look at linear graph. And so you could make a table of values, or you can use your slope and your intercept method. So let's suppose that we have this 3x minus 5. Okay, so here, when I graph this, I can graph this without making a table of values because I know that my slope is 3, right? This is our slope. This is our y-intercept. Here, I'll write that down. So our slope, just by looking at this, our slope is 3 over 1. And our y-intercept is 0, -5. When x is 0, we get -5. Okay, you don't have to write them down. This is, you should be able to do this without having to make a table. 1, 2, 3, 4, 5. So I have a point. My y-intercept is at 0, -5. And then from my y-intercept, I'm going to do my slope, which is rise over run. So I'm going to rise 3, 1, 2, 3, and then I'm going to run 1. Okay, so our slope is 3 over 1. That's rise over run. So I'm going to rise 3, 1, 2, 3, and run 1. Okay. All right, so 1, 2, 3, and over 1. And that's how I get my linear graph. Okay. Again, you don't have to do it this way. You could always just make a table. Okay, choose 3 values and graph your 3 points. Okay. Now, let's suppose that they want you to graph this linear function f of x equals 2x plus 1. But suppose they want you to graph this not the entire line. Like this is the entire line with the arrows going forever that way, right? So suppose that they want you to graph this line, but they only want you to graph it for some of the x values, not for all of the x values. Suppose they want you to graph it just for these x values from 0 to 3, okay? Well, then in this case, then I would recommend that you make a table and you use these endpoints for your x values. So we want to know what the value is when we plug in 0, and we want to know what the value is when we plug in 3, and then we can graph it, and we would only keep the graph between 0 and 3. Okay, so when x is 0, 2 times 0 plus 1 is 1. When x is 3, 2 times 3 is 6, plus 1 is 7. So we have the points 0, 1, and 3, 7. So I am going to plot 0, 1 and 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And because these are less than equal, these endpoints are going to be solid. Had this said, if it said this, strictly less than, then this one down here, this one, let me put that back. This one over here would be open circle. Okay. So again, you get the open circle if it's strictly less than. You get the closed circle if it's less than equal. Okay. All right, but this is not the problem. The original problem had that. So this will be closed. And then I can draw my line. And this is how your graph should look. It should stop here and it should stop there. It won't go on forever like this one with the arrowheads, okay? Because this is saying to graph this function only for the x values between 0 and 3. So these are the x values between 0 and 3. So I plugged in one of the endpoints, 0, found out the y value, plugged in the other endpoint, 3, and found out its y value. And then I plotted those 2 points, 0, 1, 3, 7, and my graph stays in between. Okay. All right. So let's take a look at those power functions and let's take a look at how to graph those using shifting. All right. So shifting, stretching. Okay. So let's take a look at this one here. Let's go ahead and graph this. F of x equals x squared minus 3. Okay, so if you recall, this is the parent function is x squared, and this tells me that I am going to take that parent function and shift it down 3. So because it says minus 3, so shift down 3. Okay, so my graph, if you remember the parent function, so note here the parent function is f of x equals x squared, and we have a point at 0, 0, 1, 1, negative 1, 1, and it's a parabola. Okay, so that's our parent function. So I'm going to go ahead and put those 3 points over here, and then what I'm going to do is apply the this negative 3, which is a shift downward 3. Okay, so here is my parent function. I'll just do kind of a ghost parabola. Okay, and then I'm going to shift it down 3. 1, 2, 3. Okay, so I'm going to, here, and I'll do it in a different color. I'll do it in purple. All right, so this point over here will go 1, 2, 3. Okay. This point over here will go 1, 2, 3. And this point up here will go 1, 2, 3. So now these are the 3 points of my new parabola. And that would be my graph. Okay. So any of these, if it said +3, then it would have shifted up 3 units instead of down. Okay. But since it said -3, we shift it down. Okay. All right. Let's take a look at another example. Suppose that I have this here. Suppose I have to graph f of x, which equals, so we're going to throw in more translations here. So -2 times x minus 1 squared plus 3. Okay, so let's take a look and see what all of these numbers mean. All right, so this one here, that's your up and down shift. Okay, when it's inside, that's your left and right shift. And then when you have a number here, then this is a multiplier. Okay, so this here, and this is the one we do first. And this one here, we're going to multiply. Let's spell multiply correctly. Multiply the original y values. So whatever the y values are for the parent function, they're going to get multiplied by this outside number. Okay? And we have to do that first, because if you shift it, then you lose the original points. And then it gets a little crazy. And then these two, it doesn't matter which one you do first. We usually do them one right after the other. So this one here is a shift right one. So shift right 1. Okay, so it's kind of like the opposite. And then here, this is a shift up 3. Okay, so when you see a number inside the parentheses, the grouping symbols, whatever it is, underneath the square root, when you see it here inside, grouped together with the x, that's your right-left shift. When it's outside like this, it's your up-down shift. Okay. All right, so let's take a look and see what this looks like. Again, the parent function here is x squared. All right, so parent function, we have a point at 0, 0, 1, 1, negative 1, 1. Okay, so here is my ghost function. Okay, so now I have to multiply the original y values. So we have y values of 1 and 0. Okay, so we are going to multiply the y values. This point right here has a y value of 1. And it will get multiplied by -2. So that puts me here at -2. I'll use a different color. I'll use green. This one here, this point has a y value of 0. 0 gets multiplied by -2. And we get 0. And this one has a y value of 1. And it gets multiplied by -2. So that goes here. Okay. So we have this here. I'll do another ghost function. So we have this one here. Okay. So this is what it looks like when you just multiply it by -2. Okay. The parent function. But we are doing more than just multiplying the parent function x squared by -2. We are also subtracting 1 on the inside there, and we are adding 3 on the outside here. So now I take this green function over here, and I shift it right 1 and up 3. Okay? So right 1 and up 3. Let me put some tick marks here. Okay. Back to green. Okay, so shifting this right 1. Actually, I need more tick marks over here. Okay, so we have to take these 3 points. I'll start with this one. Starting with this one over here, shift right 1 and up 3. 1, 2, 3. Okay, you can even put a little X mark if you are trying to keep things organized. This one over here, shift right 1 and up 3. 1, 2, 3. And this one over here, shift right 1 and up 3. 1, 2, 3. So now these 3 points form my new parabola. So that's where it would go. Okay. Do you have to do the dashed lines for like your ghost parabolas? No. If you feel like, oh, it's just going to kind of clutter everything up, then you don't have to. But definitely do the points. Do the 3 points and keep track of them. Do these 3 points, keep track of them. And then you can do the graph for your final one. You don't have to do these dashed graphs, but definitely you have to do the points. Okay. All right, let's take a look at another one. Let's go ahead and graph f of x, which equals to 1 plus cube root x. Okay, so sometimes this throws students off because they're used to seeing that 1 over to the right. It doesn't matter if it's written like this or like this, they mean the same thing. Okay, they both mean you have to shift up 1. Okay. All right, so the parent function is cube root x. Okay, so if you're like, oh, I don't know what that looks like, well, then just get 0, cube root of 0, 0. Cube root of 1 is 1. Cube root of -1 is -1. Okay, and this is the sideways one. Okay, so it looks something like this. Okay, and so this is just going to shift up 1. Okay, so let's do green. So I'll take this point, shift it up 1, shift this one up 1, shift this one up 1, and then this is my new graph. Okay, it should hold the same shape. The only and then it's just shifted around on the plane. The only time it changes shape is when you're doing that multiplier. Okay. All right. So that is it. You know what? Let me have you guys try one just to make sure. Okay. So go ahead and try this one. Go ahead and graph. Let's do f of x equals 2 times the absolute value, x minus 1 plus, let's do plus 2. Okay, so go ahead and see if you can figure this one out. You might want to start with, okay, listing what each of these things do. And then you can go ahead and start doing them. And remember, this is the absolute value function. The parent function has a point here, here, and here. That's your parent function. Okay? All right, go ahead and hit the pause button and come right back. Okay, so this one here is the one that we do first. And this one multiplies the original y values. Okay? This one, it's on the inside, grouped with the x. So this is our sideways motion. So this is going to be right 1. This is outside, so this will go up 2. Okay? So when you start graphing this, we have a point at 0, 0, 1, 1, negative 1, 1. This is our parent function. I won't do the dash graph. Okay. And now I'm going to multiply the original y values. This has a y value of 1. So it gets multiplied by this outside number 2. So 1 times 2 is 2. So then it goes here now. Okay, oops. Let me use a different color. Let me do this. Okay, let me use green. All right, so multiplying the y value, and it goes to 2. Multiplying this y value, it stays 0. Multiplying this y value, this one has y value of 1. 1 times 2 is 2. So now it has a y value of 2. Okay, so now these 3 green dots are my new function graph, and now I need to shift it. These 3 green dots, I need to shift them right 1 and up 2. Okay, so this will go right 1, up 2. I'll use little X marks. This one over here, right 1, up 2. That's why it's kind of good to use X marks. Okay, and this one, right 1, up 2. Okay, so these 3 little X marks are my new graph. Okay. All right, so that is it. We will focus on piecewise functions in part 2. If you have any questions, make sure you message me.